Hi friends, in this tutorial I am going to explain a program about counting the highest frequency words in the given text file. And it will give us some hands-on how to use binary search tree and sorting, etc. and traversal of the binary search tree. We will have an input file and we need to parse that and find out the highest 20 words in that file, highest or the lowest. For example, if I execute this program, let us see how it looks like. So this is the executive point. This. And we need to pass either highest or lowest. Before that, let me give it value. So here we have the one is small and two, one is big. So for me, right here, small by and I need to write highest words in this file. So it looks like there is some issue with the file. Let me try to find it. Yeah, so the program has executed now, and we can see the output. So it has created a. So these are the words which are highest frequency words in this file. The total height of the tree is 7, and number of nodes is 95. For example, I can now try the bigger file. It has something like 1,30,000 words. So let me try this. Instead of input.txt, I'll use big.txt. Yeah. So it has executed and it has given highest repeating nodes. Top 20 words. The total height of the BST is 17 and total number of words. Total number of the words in the file are 29,133. And briefly would like to explain about the data structure which I have used to implement this. And we can see this similar thing in used in Microsoft Word or some other text editors. For example, this is a text I have copied from input.txt and I have pasted here. So, for example, if you see with our previous command, how many of the are there in this files? We can see this total number of words. Let me try to find occurrence of other. So if I see there are 9 results for the which is matching our output. We will check Scrum. Yeah, it is total is 7. That is also correct. Let me quickly explain what the data structure I have used to implement this program. So in this program, I have used a binary search tree. Little bit modification that is height balanced binary search tree, which is nothing but AVL tree. So I can say this is AVL tree basically. Now in this program I had written 10 years back in 2016 as part of Nokia code competition. I am visiting now after something like 9 years, and I would like to improve this code base. When 9 years back I had written, it was written in little bit crude manner. So I'll subsequently I'll create more videos where I'll try to improve this code structure, but still this old code structure is also an informative approach how to proceed to break down a problem and create a solution for real world problem. So here what I have done is, for example, what is quickly I'll go through what is BST and AVL tree. So few words I have written, I have tried to create a binary search tree with some initial words in the input.txt file. So let's say now I try to add artifacts into this tree. So here we have already few words Scrum users most frequently inspect something like this. So then we try to add artifacts here. So yeah, artifact is added here. If with the same nodes, if I see AVL tree, it is less in depth because it has been adjusted to reduce the height, maintaining the binary search tree property. So I'll try to insert artifact here. Yeah. So if you see in the last step, the tree has been rotated to reduce the height, which is not done on binary search tree. So because of that, binary search tree will have little bit longer length to reach from root to the leaf of the tree. I'll share a link of this code base in the description below. So it is in my GitHub account. I'll quickly go to the code base and try to explain what are the different parts of the source code. So this is the node in the binary search tree or AVL tree. So it contains word. This is pointer to the word which we are storing, and it will have right pointers uh, for children and pointer to the parent if you want to traverse back to the root. And each node will contain height. The for creation and insertion of the node in the binary search tree. So what are the functions? So let me first go to this create node function. This will create new node for before inserting. So it has it needs to store string, right? That is nothing but a word which we are going to insert. So it does malloc. Since this is quite old code, here I have used malloc for memory allocation because I was doing C language. I had good grasp of C programming language. And C, you can see mostly I have used malloc. But in the next video tutorials which I'll create, in that I'll try to convert this program into better C++ program with +1. This one is for at the end of the string we need to add a null character for that. Then overall for the node we need memory. So that node will require we can find out how much memory is required with the help of size of operator. Once the memory is allocated, then we can populate the fields. Currently, we need to keep left, right, and parent as null. And because initially new node is created, we'll try to keep frequency as 1 and height as 0. And we will return the pointer to this. And then these are helper functions, print ancestors, update height of the ancestor. Yeah. Then in AVL tree, you have to and the balance. So this is the helper balance function. Other than that, you have left and right rotation. So these are the functions which implement left rotation and right rotation in the tree, AVL tree. This is the same thing which we had discussed, converting from binary search tree to AVL tree by rotation, which will reduce the height of the tree. Then next we have insert function. So whatever the new node we want to insert, new word or node. This is the function which does that. So this is all the logic to do the comparison and reach the correct place in the binary search where we need to insert. And after insertion, if height becomes unbalanced, we need to do rotation. So these are the rotations. And this is the helper function height, which gives height of the tree, height to the node which we pass. Other than that, yeah, we have already seen this balance factor. Other than that, next we have insert high frequency. So once the binary search tree is created or the AVL tree is created, we need to find the 20 highest frequently used words or least frequently used words. So for that we use an array So let me see where that array is. So let us go to the main and see how it is implemented. We need to create an array which stores high frequency words. In total, it is 20. Total highest frequency words is 20. So this is the array. So these are the helper functions to initialize the array. So yeah, if you see, it is nothing but 0 initially. Then yeah, input file stream is created. It has been opened here. So the file name has to be passed as argument to the command. Then we check whether the file is opened correctly, opened successfully. Yes. Then we start reading the data from the input file. So we have read it into string still. Then we need to get the tokens. We need to get the words from the string. So the string can be something like this. Here there are no special characters, but there are places where you have special characters or delimiters like hyphen here or the full stop, double quote like that. So those things need to be removed and individual words need to be stored. So initially, the comment, for example, you have cross function. So these are two words. One is cross, one is functional. Split it into two words. For that, we need to use delimiters. So these are the delimiters which we are using. So for that, yeah, and yeah, we have allocated memory and we are converting all the characters to lower so that it becomes easy to create the tree and not repeat the words if they are not case sensitive. We are not considering case sensitivity, so we are converting all the words to lower so that it becomes easy to count the frequency of those words. So if we have such kind of words, we need to create split them and create two words out of this. For that, I have used string token. So what this is, let's say cross-functional word is, so it will first give us cross. It will check if any delimiter is there. For our case, yes, hyphen is there. So it will take only the first part before the delimiter cross, and it will be written as token. And this like first we have got cross, so that token will be cross, and we need to insert that token into the binary search tree. And again, we need to get the next token. So if we execute this function again, string token with null and delimiter, it will continue in that order and will give us the next token. Next token is nothing but functional in this string. So next time token will be functional. So while token is not null, it will go and insert a functional word into the binary search tree. All the words will be inserted into the binary search tree. And a binary search tree, nothing but height adjusted binary search tree, nothing but AVL tree will be created. At the end of this file, we will get a binary search tree containing all the words in the input text file along with their frequencies. So once our tree is ready, now we need to pass it and get highest frequency in the input command line. We can pass either highest or the least words which we need to get. For example, let me take highest. So if it is highest, then we need to extract the highest frequency 20 words from the tree. So let's see how that has been done. So we are passing here array, which will extract element function will parse through the AVL tree and will populate this array. So let's go to the extract element function. So if you look here, extract element function, so it does invite a traversal of the binary search tree to extract highest frequency as well done in what I say recursive manner. So first I am parsing left and inserting that calling insert high frequency function. So let me check what is that function. This is for in order traversal basically. You traverse left, then do the insertion and traverse right of the binary search tree. Let us go to insert high frequency function. What it is. So this insert high frequency word function basically uses insertion sort. For example, if we want to see an example, some numbers are given like this, and let's say we want to insert this 5 in this array at its proper position. So it will push all the elements and it will try to find where is its position. So now it has got its correct position. Similarly, next 35 needs to be inserted. So till 40, it is a sorted list. Now new element 35 needs to be inserted. For that, it will try to find out its position. Now it will check with 30, which is less, so it will stop it. So it has 35 has found its correct place in the sorted array. So till 40 it is sorted. Fifth 5 index 5 it is sorted now. Next it will try to insert 25. So for that it will try to find its proper position. And now it has found the proper position. Like this it will like this we will have our insertion high frequency words. And every time a new word comes while traversing the AVL tree, it will. So this was just brief about insertion sort. Now let's go back to our code. So now that we understand insertion sort, I'll not go into the detail of this function implementation. You can see it for yourself. So order 1 was for highest frequency word and order 2 is for least frequency. Now that we understand how we populated high frequency words into array, now let's go and see bottom. Yeah. Once that array is populated, we just print it for just for us to see. Now let's go to the terminal and execute the bonus. Yeah, we can now relate it better. Now, so this was a small file input.txt. Let me execute a bigger file and see small. Yeah, it takes some time, but it will give us the required output. So these are the high frequency words. And it has occurred 80,000 times of 40,000 times like. And the height of the BST is 17. Total nodes in the BST is 29,000. And that I will share the link of the GitHub project in the description below. I hope so. This was a very old code written by me when I was knowing only C programming language, and now that I know C++ programming language, I'll try to rework on this code in the future tutorials and make it better, readable, maintainable code. Thank you so much. Hope this helped. Happy coding. Bye.